Good afternoon, everybody, and welcome at this 11th edition of TKI Wind op Zee Live. My name is Sophie van Hoytema, and I will be your host for the coming hour. To achieve our ambition for a sustainable society, we need to install a new wind turbine every other day for the coming 8 years. What a huge task we have. Well, in this edition, we'll discuss robotization and human capital as the answers to the much-needed capacity to realize the offshore renewable energy transition. First, we're going to start with a short report of our vlogger Larissa, who interviewed Sander and Christian. They are 2 students that want to work in the offshore wind industry. What does this generation that will fulfill this huge task expect from their future? Let's take a look.
Over enkele jaren leveren zij een belangrijke bijdrage aan de energietransitie op zee. Krijgen zij van alles te maken met robotisering en automatisering? Waar komt hun passie vandaan en hoe zien zij de toekomst? Welke opleiding heb je gekozen?
Ik heb zelf gekozen voor de minor Offshore Renewable Energies.
Dat is een hele mond vol.
Ja, klopt.
Wat betekent het precies?
Het houdt eigenlijk in windturbines bouwen op zee. En dat gebeurt in Nederland heel veel momenteel. Steeds meer. En we gaan naar 20 gigawatt in 2030. Dus een flinke hoeveelheid.
Wat houdt dat in? Hoeveel windmolens zijn dat?
Nou, dat gaat wel richting de 1500. Dus dat zijn er heel veel.
Oké, en waarom heb je voor die opleiding gekozen?
Nou, ik hou zelf heel erg van werken met grote installaties. Nou, en dan trekt iets als offshore je zeker.
Het komt eigenlijk vanuit mijn vader. Die zit al 20 jaar in het vak.
Wat leuk.
Die geeft toevallig ook les op de opleiding zelf.
Leuk. Dus eigenlijk in de voetsporen van je vader ben je gereden?
Eigenlijk wel. En volgens mij vindt hij dat ook wel ergens wel leuk. Is wel eens trots.
Want hoe zie jij jezelf dan over 5 jaar bijvoorbeeld? Waar zie je jezelf werken?
Nou, ik denk zelf dat ik bij een van de grote contractors hoop te werken. Dus bij de DME, de Van Oort, noem het maar op. En ik hoop zelf dat ik ook daadwerkelijk mee offshore kan gaan. Dus ook mee op zo'n boot, echt het water op. En niet alleen dus bedenken wat gaat er nou gebeuren en hoe gaan we dat doen, maar ook het echt uitvoeren ervan. En dat is wel iets wat me echt trekt.
In de offshore windsector zijn ze nu heel veel bezig met robotisering en automatisering. Hoe kijk jij daar tegenaan?
Nou, ik kijk tegenaan als echt een vooruitgang is binnen ons werkveld. Niet alleen kan het onze uitstoot verminderen, omdat we minder vaak naar onsite toe kunnen we door automatisering ook heel veel dingen offsite doen. Dus dan kunnen we gewoon eigenlijk met computers er naar kijken. En het is een stuk veiliger voor de mensen. We hoeven niet meer zo vaak de molens in. Dus eigenlijk brengt het heel veel voordelen met zich mee.
Waarom zou iemand voor deze opleiding moeten kiezen?
Nou, ten eerste is het de enige opleiding over offshore wind in Nederland.
Deze opleiding is heel erg gaaf, want het is echt een mengelmoes tussen de techniek en de plannende aspecten.
En daarnaast is duurzame energie de toekomst. Ja, en er zijn gewoon heel veel mensen nodig in deze wereld. Dus baangarantie is ook een zekerheid.
Well, that was good to hear from the next generation that will be working in the offshore energy transition. Let's start our conversation at the table here in a minute, because first I would love to invite you to participate, you, our audience, in this webinar. So if you have any question for our guest, please feel free to ask them via the chat if you're watching via the website. And also if you're watching on LinkedIn, post your questions in the comments. Please do so, because Bob Meijer here will keep an eye on all your questions and we'll ask them here at the table. Let's introduce you a bit more formal. Welcome, Bob Meijer.
Thank you, Sophie.
Director of TKI Wind op Zee. Bob, we've just heard the next generation that will be working in the offshore energy transition about their motivations and their expectations. What is your impression?
Yeah, I think it's really great to hear that they really radiate this passion for renewable energy, the energy transition, working with large installations, but also with things like robotics. And it's also interesting to see they don't see robotics, for example, as a threat for jobs, but really as an opportunity and a way to make the energy transition happen. What also struck me is also the safety aspect. Sometimes we tend to maybe not put it in the spotlight if you talk about robotization, but less people offshore means also safer working. So very interesting to hear from these young people.
Yeah, well, we're going to talk a lot about the robotization and of course their future work. But first I'm going to introduce the next person at our table. Very pleased that you're here, Barbara Oomen.
Thank you, Sophie.
Welcome, President of the Board of the HZ University of Applied Sciences. Barbara, we saw your students in the intro. You must be proud, I think. How popular are studies for the offshore wind sector?
Yeah, well, I think students are your best ambassadors. If you hear them speak about also their studies, it's wonderful to hear. Well, yes, we have this minor offshore renewable energy. We've had it since 2018. So every half year we have students who work on this topic for half a year. And our students are partially Dutch, but also international. So they come from all over the world. And every course, we have about 25 students. And I think what's really special about the program is not only the topic, it's the only minor in offshore renewable energy in the Netherlands, but also the way in which it's taught. Because what I think what they also like so much is that really half of the time and half of the teaching is done by people in practice. So people from the field, from companies we work with, who really train the new generation. And then the other half is also very much working on innovation, working on practice, etc. So it's a true cooperation where, of course, our people organize it, and we have a professor in Delta Power who speaks about the role of wind in the energy transition and about the history of wind and offshore renewable energy. But generally, it's also not only the theme is special, but also the way in which the minor is taught. And it's about 25 students.
And is that popular then? Can you say that's a large amount, or do we need to promote it more?
Well, okay, so we call ourselves the personal university. So a group of 25 is nice because you can pay personal attention, etc. And students love that. I think if you look at the bigger picture and what a wonderful job this is in this field, what a wonderful field it is, you'd really want more students to come in.
Oh,
yes,
that's good. Let's talk about that a little bit more later on. Let's first go to Koen Hermans from TNO. Welcome, Koen.
Thanks for inviting me.
If we talk about robotization, what technologies do we mean?
Yeah, so I see robots as mechanical devices that can perform an inspection or perform some maintenance for you at exactly positions which you might not reach as a person, or perform tasks that are dull, dirty, or dangerous.
Well, the 3 Ds.
Indeed, yeah. I think there's a fourth one called dare, if your asset is dear to you. But yeah, I believe robotics is a very exciting development, but we don't see it being applied in offshore wind that much yet. And we see the challenge we have with finding enough skilled people. And we believe that robotics can play a part to increase the uptime of offshore wind turbines.
Yeah, okay. We'll talk about that a little bit more later on. But how far are the development of the solutions you have for?
Yeah, so for me, a robot can also be a drone that you can send to a wind turbine blade to perform a visual inspection. And those are already being used almost commercially in the offshore domain. But there are also certain tracks that still need a lot of more development and testing before it can be applied in the commercial offshore wind farms.
Okay. Well, last but not least, we have Bernadete Goncalves-Castro here from Royal IHC. I put it on in letters here. So IHC. Bernadete, do you think it is possible? It will be possible for the maritime industry to install the more than 1,300 wind turbines in the next 8 years?
I think it's
the maintenance.
Yes. Yeah, it's a big challenge, but I think we can do it if we work together. And I think we need a lot more installation equipment, but also smart installations. So you will need some kind of automation. I also find the word robotization very narrow. You need a smart automation to be able to do it, and robotization is only one aspect of automation. And you will need, of course, a lot of the things that are not discussed so much in the maritime sector. There's data analysis, machine learning, that all comes together with the needs that you need to be able to achieve this huge task, because we don't have the people to do it. That's one of the big bottlenecks. So we will need to find ways to do it with very few people, and maybe people from land doing, you know, with their virtual reality glasses or whatever, watching the operations in the sea. So the digital transformation will also help a lot, I think, but it's still a huge challenge, and I think we really need to collaborate, the maritime sector, the energy sector, to make this reality.
Lots of collaboration, and I think you already touched the subject also, the very tight labor market, as you were saying, in particular for more the technical roles, I think. How do you view, what's your view on addressing this issue?
Yeah, well, first, for developing the next generation wind turbines, we try to design everything out that you don't have to go there anymore. But what we do see in the current state of technology, there are still routine inspections that need to be performed every year or every 2 years. And for that, you need people. And with the number of wind turbines we're talking about, there's increased strain to those people.
Yeah.
Yeah.
Maybe I can add on that one, because I think it's both true. On the one hand, you want to have everything as automated as possible and work on robotization, etc. So it's definitely something to discuss. But just like you say, you always need people. And one of the things I just spoke very much about, say, my own university, but one of the things you see happening in Zeeland as well is the vocational school. So you have SCALDA, which is a vocational program, where also the mechanical engineers, the electrical engineers, they also, there's this training on offshore renewable energy, and there you see 40 students doing that a year, and quite a few ending up in maintenance positions. So I think in terms of the human capital, it's whatever we design, I think that there's still this need for human capital there, which I think we should address.
Yeah. Wouldn't it be nice if they can actually stay assured that they don't have to make this dangerous transfer at sea?
Sure, of course, yes. So there, I think that's where the future is, and that's where really our innovative power should be, definitely.
Yeah. So we'll be instructing and steering the robots that work offshore in that case.
Yeah.
Yeah.
Well,
that sounds like
something we're working on very much.
I would like to add also that even not only offshore, but also on our shipyards and our colleagues in the Netherlands, we already see the lack of human labor, qualified human labor. So we started introducing robotization on welding, cutting, some activities, the dangerous and the dull.
And the dear the people can do.
Yeah. And now the people that used to be doing it by hand, they are now pressing buttons. So they are also educated, maybe get a better salary. So I think if we do it in a good way, there are chances for everybody. But what we see is that it's not like what happened in the automotive industry, that people introduced robots to lower costs. We need robots because we don't have people anymore. Yeah. At least not enough.
Barbara, are you optimistic about finding those people and educating them, the large numbers we need? Because you always said there are other mechanical studies. They're also. Are you going to find them?
Well, I think we could and should do more, and this applies to all, say, technical jobs in the Netherlands, although I agree with you that it's not only technical jobs, you need interdisciplinary skills, but I think in the Netherlands also getting young people interested in this type of career is so important, that this is just also a very interesting and cool kind of thing to study. So there, for instance, if I look at what we do in Zeeland, we really try to, from primary, secondary schools, to also having people in the MBOs or the vocational schools, then possibly continuing to an HBO, so an applied sciences program, etc. So I think there's much more we could and should do, because the shortages are there, and at the same time the excitement is also in the innovation, also for students, because we have a number of research projects in this field, and there I see that students also so much love contributing to well, for instance, robotization. Yeah,
that's then a double-edged sword. I mean, people being trained on, for example, robotization, lowering the pressure on the labor demand.
Well, I think it's the story of higher education these days, that we train people for jobs that probably won't be there anymore in 5 or 10 years. So you need, on the one hand, you need to do really good skills training, and at the same time, flexibility, interdisciplinary thinking, design thinking, etc. That's as important.
Yeah.
So we want the human to stay on shore and not go to sea. Bernadete, at what point is that going to happen in future? Look in your...
I think it can already happen for a certain extent. And what's holding it back is legislation now.
Okay.
That you really need, for example, you need people on board, so many crew, so many... That's, you know, that these are legislation laws, but technologically we could do it less. And I don't know at which point 0 people will be on board. I think that last few people will be very difficult. But we already have, for example, technology for our vessels where they can sail and work autonomously, but it's not allowed. But they could. And I think that's maybe, I always say 10 years, but maybe we'll see it in 5 years. The world is accelerating, so I think we will see it very soon. And I think it's also a way of getting more people, because the young people that I've talked, they work on the sea, but at some point they say, okay, I want to start a family. I would have a bit more stable life. And then they quit the job and they go do something else. And I think that would, you know, also be a double sword, a double-edged sword to get more people and keep them.
So you really say that autonomy is already possible in terms of, for example, installation type work, installation vessels? Or
for installation specifically, I'm not so sure, but I think we are quite away on it. But maybe you can tell even more.
I'm not sure if I fully agree that in 5 years the robots will already replace all of the maintenance tasks, because some of this work, it's really hard to replicate with a robot. But in the applications where you already do see robotic concepts being applied successfully, yes, we will see those more and more in the coming years in the current wind farms. But yeah, we need to start developing those next generation solutions now, because that also takes a certain period to get used to, get introduced at certain front runners in the industry, and then slowly you will see them taking over more and more of the wind industry if it's effective also.
Yes, yeah, maybe I should be more specific. I think we will see them, but they will not replace the human people. I think we will see the introduction.
Okay.
Barbara?
I'm thinking of one of the big projects we're working on at the moment. It's Zephyros. It's a Fieldlab Zephyros is the name, and
we'll talk about it more later.
Yeah. Okay, well I can tell you everything about it, because that's very much in line with what to me seems to be the future. Although I must say, I find as a lawyer, I find it interesting that you mentioned the law being in the way, because I think this is what you see a lot in the energy transition, that it's more the law, governance, etc., than the practical solutions not being there. And I think this again
what can you do about that?
Well, also make sure that in energy transition projects, so to really set up specific projects, so think about a wind farm at sea, and maybe also a wind farm with multiple functions, also in terms of solar energy, etc. And in designing, making sure that you involve all disciplines, so also biologists and psychologists and lawyers, etc., to come up with the best workable product. So.
I would like to go to a company now that's active in the maintenance for offshore wind farm and has built their own unmanned vehicles. So joining us online is Jan-Jelle Huizinga. He's an R&D project manager from Bluestream Offshore. Welcome, Jan-Jelle.
Thank you very much.
Hi, welcome. So what is it that your company does? Can you tell us?
So Bluestream Offshore is a service provider, inspections of installation of equipment, repair of equipment. We do this with 3 different aspects. We do rope access, diving, and with ROVs. So that's our core business.
Okay, I hope everybody can hear you, because sometimes there's a little. Do we see the technique? Yeah. everybody? Yeah, you're being heard really well, so very good. Let's continue that. You've decided to develop and build your own unmanned vehicles. What prompted you to automate and robotize work?
So ROVs typically are already remotely operated from a vessel. But what we've noticed in the market is that there is a big demand for ROV-based inspections. A lot of inspection work is used to be done by divers, or is still done by divers, but clients request more and more to do this only with ROVs. Now, there are already a number of inspection examples, inspection tasks that can be done with an ROV. But there are also inspection tasks which are simply too complex to do with ROVs. So there are some recurring tasks which were done by divers, and we build tools which we can then connect to our ROV to then perform that particular task. So it's really in that sense a client-driven request to perform ROV-based inspections.
Yeah, and how do you? Yes, yeah, go on.
Well, the problem is that the ROV that we have and the ROVs available in the market typically are not suited to do these tasks. For example, weld scanning, or scanning a probe over a material to do measurements. This is something an ROV is not designed for, the basics of an ROV. And also there's no tool in the market to perform this inspection. So therefore we decided to build this ourselves.
Yeah, yeah. And what challenges do you, those challenges you have, and do you, my question was before, how do the employees react to having those tasks and performing by machines?
Well, generally positive. As the ROVs themselves were already used in the industry, so the employees using the ROVs are now also using those tools, and those employees are typically very enthusiastic that we are diving into these development challenges, and they're really keen to get on board to be a part of these developments as well. So generally very positive feedback.
Good, good.
Yeah, maybe Jelle, a question from my side. You say you work on say inspection type work, but in the work that you do you also encounter new tasks where you think, well, this could also be say automated or done with the help of robots or?
So the inspection tasks typically are very written out, if you will. So the scope of the inspection is typically clear, and there are certain inspection measurements we need to do. There's a visual inspection we need to perform. We need to record this and then make a report, which is the end product for the client. But on the installation side, we do see that there are specific tasks which in installation or in design phase, I should say, are designed to perform with divers. Then in the contractual phase or the installation phase, the client says we actually want it done by ROV, and then we design a tool to install the equipment that originally was designed to install with divers. Then we design a tool or a vehicle to install this with an ROV.
Well, thank you, Jan-Jelle. And you will be staying in the call, I think, just to, if there are any questions for you, or maybe you can participate if you want. So you will be staying. Thank you so much for elaborating on this. So the robotization also raises new questions about our work and training. We'll discuss that further with our guests on the table. But for you, please feel free to ask questions because we're here. And we'd like to answer those questions that you have as also. Bernadete, what new demands arise for employers and employees with robotization for you?
Well, they need to be trained. That's because it's a all new field, and they need to learn a bit about programming, about the electronics of the robots or automation. So it's quite something quite new. While there's still, for example, a welder still needs to know how to weld. And then they need to know how to use these robots that are helping with welding. So it's a bit of a change. But we are already considering, because we see this coming more and more, also already at a vocational level. We have our own training institute. And we are already going to introduce a robotization technology for production to be able to accommodate this need and also the scarcity of personnel, so that we can guarantee that they know how to use the new technologies, and that, of course, the work is safer and fun also, because it's an important part of that everybody likes to work with the robots. It's one of the interesting things somehow. It's I think some people find it horrible, like the Terminator, but there's the other part of the world that really enjoys seeing how robots can help you with all different tasks.
Yeah. And maybe a question about, because you're working within the supply chain of offshore wind, really at the core of this. But the industry itself is also very much in development. It's changing all the time, with new requests for equipment, ever larger turbines. And our previous webinar was also about standardization. And I just wonder, say, if you don't standardize, and every time there is new equipment that you need to manufacture, larger turbines to install, would standardization be also a solution to be able to robotize the actual things that we're doing? That the robots are not obsolete maybe in 3, 4, 5 years' time?
Yeah, I think it's absolutely necessary. Because, as our colleague said, robots can only do the dumbest part of the job. And you still need the person, creative, smart person, to look over what the robot is doing. So standardization is really necessary. And that's something that we are also struggling with already in the shipbuilding, because we really need to go to more standardization. But somehow you need to keep the flexibility, because every vessel is slightly different. So it's a big struggle how to do, how to introduce that level of automation in a custom-built world. Yeah. And that's a struggle that we are trying to tackle. And I think the answer is make smarter robots and make a bit more use of people, smart people, than normally what you see in the car industry. The factory is empty. I don't think we will see that very soon in the maritime sector. But I think making smarter, flexible robots will help us get there. Yeah. But standardization is necessary, otherwise everyone goes crazy.
What is your view on that?
Then will the wind turbine be standardized or the robots?
I think both. I think you need both. Otherwise,
how do we ensure that we keep innovating if we keep running on, say, 5-year-old technology?
That's a big question indeed. But I think we need some level of standardization. Even if you want to install one turbine every 2 days, you cannot be rethinking the procedures every time. So there needs to be some standardization. I think it's also a challenge how to keep innovating with the standardization. But good question.
And we need to think of common interfaces that we will
that you can build on. Yeah, maybe more modular. I think what we see is also in our vessels is that modularity at different levels, not only at ship level, but also at hardware level, software level. It will help us keep innovating without every time having the huge investment. So, but I think, but it's a challenge to our creativity.
Barbara.
No, what I found interesting at the beginning, because somehow when I think about robotization, I always think about maintenance and, the moment that, for instance, wind turbines are already there. But what I got from what you said in the beginning is that you're also thinking about the actual placement as something that could be more automated. Is that also where, say, more standardized ships, modular working comes in, to have that part of the supply chain?
Yes, I guess so. Especially if you want to do it faster, then you will need this standardization. You will also need vessels that can stay longer at sea, because I think one of the issues we have in the North Sea is workability. That I think 100 days a year, something like that.
Yeah, it's like.
And I think we need to extend how far you can work with your vessel in bad weather. And at the same time, if you don't have so many people and you have machines, then it's also not so critical. If something goes wrong, at least you have only machine losses or damage. But I think there's some, that all, and of course, workability is also an advancement in automation that we need to achieve.
Yeah, sorry.
No. If you talk about, for example, workability, be able to transport through, for example, high waves, and maybe autonomous vehicles are better in that than vessels steered by humans. I don't know. That could be the case.
Would be nice. They don't suffer from seasickness.
Indeed. But I think you need to teach them well, and that's the bottleneck of all artificial intelligence.
This is also where the legislation comes in the picture again. Of course, who's responsible for that vessel?
And algorithms, because I know they just launched an automated vessel in the harbor of Flushing, and the key of this little boat is that it learns while it does. So every trip it gathers information and it gets better and better at
doing it.
Yeah,
and that's something that we are doing in, say, in our kitchen. Also developing these algorithms that are fast enough. They must be good enough, but also fast enough to solve your problems in real time. And that's really a challenge, especially the workability of vessels. But I think we're getting there.
Exciting.
So how are we getting the robots accepted on the work floor, Koen?
Well, that I think we need to have a good conversation with the current workers and explain to them what robots could do. If you tell them that you don't have to go to that many turbines anymore during the day, that might also help them accept it. But before we can introduce those robots, they need to be there. That's something we still have to develop. So in that sense, especially when thinking about maintenance, it's very hard to replace a technician with a toolbox, because you need to, everything in a wind turbine is designed for human maintenance. And maybe we can show an example of what we did in our recent test with the robot arm trying to flip some switches. There you see that we did this with the cobot, so that's a robot that's designed to work with people in the same room, being safe. But we had to teach this robot arm really to go to location A, flip a switch. You see the actuator is already pretty large. And just perform 2 switches. This is something, of course, you want to design out to do from a distance. But now we were there to really guide the robot arm and see exactly what's doing. But if you want to do this from a distance, from your safe home office, you need to really think of how do you control this robot arm from a distance. And that's really still a whole journey we're on to find that out.
And what does it require of our education?
Well, doing these types of projects, I think this is one of the things I'm most excited about. Really practice based learning. So can I say something about this air tub I'm so excited about? Because I think it's an example of this. So you must imagine in Vlissingen, in a big hall, there's a what do you call it? A wind turbine? Blade. Massive blade, enormously big. And there a whole group of researchers and companies and our lecturers and students are working on a remote-controlled crawler, a prototype that one day, with a remote control, can crawl through such a blade and do whatever has to be done in terms of maintenance. And this is very much now in the prototype stage, trying things out. They also speak about a different, like a drone that can do coating, for instance, also another maintenance issue. But I think this crawler and working on that crawler from different disciplines is also something that's very much built in the studies, but at the same time, it's real time. It's something that's being developed that will be scaled up soon. So education is not something for later, but it's really together with companies, etc., happening there. And of course, the students are so super excited to be part of this, that they also want to be part of the next steps. And then you often see maybe engineering students suddenly taking up a real interest in ICT or in other fields, because that's what you need to solve the problems that you run into. So,
well, yeah, well, yes, Bob.
Yeah, I see there is also a question from Jan-Jelle, in fact, to Koen. Jan-Jelle, please go ahead.
All right, thank you. Koen, just a question about the video we saw earlier. I can imagine this is also an example to show the dexterity of the arm in terms of the cobot and how to use this. But in terms of maintenance required or certain tasks to be done with switches, I can imagine the development in automation of the individual switches over a wireless network connection is something that could also really help reduce the maintenance requirements for a cobot, as those switches can, for example, be read externally and controlled externally. Do you know anything about the development of this?
Yeah, this is a typical example of something we would like to design out. So avoid someone having to go there to flip a switch. That's why condition monitoring is so important. But we do still see that maintenance tasks can also exist of troubleshooting. And then you need to go there, open a door, make a picture, see what's happening, do some measurements. And that's something we are looking a robot arm to perform those kind of tasks. Yeah. And there's still, of course, the legacy wind turbines that we will have with still switches.
Yes.
Yeah, while you're here, Jan-Jelle, I see also a question from the audience. Was standardization needed for your innovation?
That's a good question. In terms of procedure, for example, if I take our development for the weld inspection robot we made, or the weld inspection vehicle, there is a standardization and a procedure of how to use the technology used for the weld inspection, which is alternating current field measurement. This is a certain technology to inspect the weld on surface breaking defects. And there is standardization on that technology, how to use it. There's a procedure on how to report the defects, etc. So our tool needs to be able to cope with that standardization or that procedure. But in terms of development, the actual designing, there was no standardization.
Okay, thank you. Yeah.
Thank you so much, Jan-Jelle. And Barbara, especially for you, you were talking about Fieldlab Zephyros. You're very excited and enthusiastic about it, of course. We had our vlogger, Larissa, go there.
She went there.
Went to Fieldlab Zephyros, and where she spoke with Ferry Visser. At Fieldlab Zephyros, parties from the entire value chain are working on minimizing downtime of wind turbines at sea, with the help, of course, of the robots. Yes, so let's take a look at this vlog.
Het aantal windmolens op zee stijgt in hoog tempo van honderden naar duizenden. Maar hoe worden deze allemaal onderhouden? In deze vlog ga ik langs bij Fieldlab Zephyros om dat uit te zoeken. Zegt het eigenlijk al. Jullie zijn hier een soort testlab, maar wat testen jullie hier precies?
Ja, nou, je hebt helemaal gelijk. Wij zijn een soort testlab, maar we doen meer dan alleen maar testen. Want we stellen bedrijven in de gelegenheid om hier te ontwikkelen, te testen en te demonstreren. Dus je kan hier eigenlijk het hele proces, kan hier gefaciliteerd worden op deze plek. Dus wat wij hier doen, dat is wij richten ons op het terugdringen van het aantal mensen wat offshore moet om onderhoud aan windmolens uit te voeren. Met de personeelskrapte die er nu al is en de opschaling in offshore wind die eraan zit te komen, zijn wij ervan overtuigd dat we ervoor moeten zorgen dat die windparken zichzelf gaan onderhouden. En daar hebben we digitalisering en robotisering voor nodig.
En ik zie daar ook nog wel iets heel leuks staan, maar mogen we even naar binnen?
Ja, natuurlijk. Dat is onze trots. Dat is onze indoor nacelle om te leren en te innoveren. En we kunnen erin gaan.
Nou,
we moeten wel even een helm op.
Met welke bedrijven werken jullie allemaal samen?
Nou, eigenlijk werken we met de hele keten samen. En dat betekent dat we natuurlijk met het bedrijfsleven samenwerken. Dat zijn zowel de grote bedrijven die zich bezighouden in deze sector, maar ook het MKB, waar de slimme technische oplossingen vandaan moeten komen. Daarnaast werken we samen met kennisinstellingen, Denk aan TNO. En tot slot natuurlijk met het onderwijs. Want dat vinden we heel belangrijk. Dat we het onderwijs betrekken bij die innovatieprojecten.
En waarom vinden jullie dat zo belangrijk?
Nou, uiteindelijk moet nu de monteur van de toekomst opgeleid worden. En die monteur van de toekomst moeten we ook opleiden met de technologie van de toekomst. Dus die moet meegaan in die innovatieprojecten.
We zijn nu naar buiten verplaatst, maar waar zijn we nu?
Ja, nou, we zijn op het achterterrein van ons Living Lab. En daar zijn we op het moment aan het testen met het watersnijden van een oud turbineblad. TNO die wil daar een proef mee doen. En we hebben hier een watersnijmachine staan. En dan kan een oud turbineblad in stukken gesneden worden daarmee. Op een milieuvriendelijke manier.
En zijn er nog andere uitdagingen waar de sector mee te maken krijgt?
Nou, eigenlijk de grootste uitdaging voor de toekomst in de sector is zorgen dat al die windturbines op zee straks ook energie opwekken als het waait. Dus we kunnen ons eigenlijk niet permitteren dat er nog windturbines stilstaan. En om dat te bereiken hebben we smart maintenance nodig. En dat is natuurlijk waar wij ons elke dag mee bezig houden.
Ja, wat betekent dit voor het Fieldlab Zephyros?
Nou, voor Zephyros betekent dat er heel veel nieuwe vraagstukken zijn om uiteindelijk naar die zichzelf onderhoudende windparken te komen. En daar moeten we nieuwe projecten voor hebben, nieuwe ontwikkelingen doormaken, nieuwe innovaties testen en demonstreren.
Dus genoeg werk te doen dus?
Heel veel werk te doen.
Je hoort het misschien al achter mij, maar ze zijn nog druk aan het testen. En ik snap nu hoe belangrijk het is wat zij hier doen.
Yes, Ferry showed us with great enthusiasm the work of Fieldlab Zephyros, shared by Barbara, this enthusiasm. Let's continue our talk about robotics and the human capital. But if you have any questions, please ask them via the chat.
Yeah, maybe there is a question from Augusto who makes a remark that the challenge with a robot inspecting a turbine is that the robot is alone. While if the safety regulations dictate that there must be at least 2 technicians in the nacelle. Yeah, you could of course argue that's saving people and time in terms of activities. Or do we also need somebody to monitor the robot in that case? Can robots really work alone?
You need to take a good eye on the robot of what the robot is doing, because it's your asset. It's messing with, or it's trying to perform maintenance, I should say.
Fixing.
But this is specifically something we need to add to the roadmap of towards market introduction to make sure that those. Yeah, you could also see as legislative roadblocks are taken away, but that needs demonstration of those new solutions, and everyone in the chain to be convinced that indeed it's safe to have this robot operate remotely.
Yeah.
It's also, I think, because many of the laws we have today are based on the situation 50 years ago. So the idea that you need 2 people is related to the safety of those 2 people. Yeah. And as you say, it's sad if somehow your robot or crawler gets destructed or falls into the sea. But it's less sad than when it concerns a human being.
Yeah.
Koen, can you describe the importance of field labs such as Ferry was talking about for innovation?
Yeah, you saw in the clip of Ferry that we as TNO we really like to move the thoughts from paper into a field lab like Zephyros to really learn by doing and also demonstrate the robotics in a realistic environment, because it has been a commercial wind turbine. It's actually much tighter than large wind turbines, so maybe even more challenging to operate a robot in. But we are really looking forward to invite also other parties in the Netherlands to join us for this, because it cannot come only from Applied Research Institute. We need to work with industry, looking maybe a bit further ahead for which tasks can those robots do and what are the requirements for those. And then we can bring in all the technology to solve that.
Yeah, I think it's a great call that you make here. I think, and of course from the TKI, we have an innovation program that is built on collaboration. So knowledge institutes, universities, education, but of course companies that also work on innovation together to solve these major issues or challenges that we have in upscaling offshore wind. Anybody who's has a good idea, please contact us or anybody around the table, I would say, to launch this idea and see if we can work together.
If you're at home, you can also say it in the chat.
Yeah, please get in touch.
Because I think this is really the future. Also partnering around a specific issue. How do we also maintain wind farms? How do we go about that? And then having all parties on the table. And what I like about this is that you have a combination of research and education and solving the human capital issue and working towards the future. So, and there maybe it's good to mention that what we saw just now, this physical place, the CAP, is also on something called the Kenniswerf, the Knowledge Wharf, which is very much for that purpose. So it's a place where companies are welcome, where different parties are there to also do research, teaching companies, and to also meet each other. And I think that's very important as well, that you physically work together in a place like this.
Absolutely,
like this.
And what do you need? What does your industry need from educations to make?
I agree with what you're saying, and we need to keep. Actually, people need to be learning their whole life to be able to go, the technological developments. But what I see also as a big obstacle for us is that we are often ready to try things, but either there is no funding, because when you go from paper to objects, the cost level is 10 to 100 fold, and also who's going to guarantee, who's going to take on the risks. Because suppose we are working, doing some nice robot trial or automation trial with the vessel gets damaged, the wind turbine gets damaged. Oh, then we have a problem, and who's paying exactly? And that's really an issue in the maritime sector, because whenever something doesn't work anymore, the costs are so high, and the responsibility, the insurance issues. So there are a lot of non-technical issues that are slowing it down. Yes, and we would really like to see how we can work with different parties to try to find a way through this wood.
Yes. I think Jan-Jelle wants to respond at this moment. Yes, Jan-Jelle.
Yes, thank you. Actually, I wanted to respond in a similar way as Bernadete just did. What I find in the industry as well is the offshore industry in general is very conservative. And this is very logical, because operations are very expensive. Vessels are very expensive. Operational time is expensive. And also downtime on weather creates high costs. So typically companies are very reluctant to change what they know works, because they can estimate on this. They can calculate risks. And this also poses some challenges for us to convince companies to do it in a new way. For example, installation of certain equipment on monopiles, on wind farms, like ICCP cells, sonar transponders. Instead of doing it the way that they know will work, do it in a way where we can automate the process or use a remotely operated vehicle. To convince these clients has taken quite a while, and this is still a challenge. We have now, we're in this a few years now in actual development of tools, and I noticed that it starts to work now as some clients who know us now come back because they have the confidence that we can do that. But the conservatism in the industry is definitely an issue in terms of innovation and moving forward.
How can we act on that?
Well, I think there's a real role here for the government, for the public authorities, for say public money to help develop materials. It's such a way that they become marketable. You need companies to have the questions articulated and the issues on the table. You need research, you need teaching all together, but at the same time you need public funding, just like you see a lot now with the Groeifonds and RVO. Of course, there's funds like that. out there, which I think are key in making the transition. And again, I think Jan-Jelle is very right where he speaks about the industry being conservative, etc. But what we find is that often in working together with industry comes with say a small question, etc., and they work together with students. But also, for instance, we have 19 lectoren, so professors in different fields, half of which engineering. And then in working with them, there comes another question, and there comes a plan for a project, and there comes an application for a project, and before you know it, you're innovating together. And I think that's also really important. And I think for that, like well, they call it ecosystem. So just just knowing each other, finding each other, starting with the small internships and then ending with a big collective project. I think that really is something I've seen work really well.
Fieldlab Zephyros is an example of that.
Very much so, where you really see that, and where you also can't say like who is innovating here now? Is it industry?
It's really a joint effort.
Is it? It's really joint effort, and out of those contacts, and out of this, now it's about the crawler, and there's the drone spray painting, well, doing the coating. I'm probably not saying this correctly, but anyway, there's other ideas. So out of this, these contexts also come new ideas for innovation, which also really help, I think, innovate maybe a relatively conservative sector, and also pull in different disciplines. So not only the engineers, but as you say, the ICT, the robotics people, etc.
Yeah, we had once a very interesting project, and we worked with Groningen University with the philosophy, with ethics people.
Oh, wow, yeah.
Just look at the ethics part of innovation. It was really was very interesting, because we realize, we can be completely ready at the starting point to introduce something in the market, but if the society doesn't accept it for some reason, then you really have a problem. So it was very interesting.
Yeah, but these field labs are also created to de-risk these innovations and to make them acceptable to the market. You can demonstrate them, people can see that they actually work, and then slowly on this can be picked up by the market in real projects. I think also you mentioned, support from public funding. This is very much where the TKI Wind op Zee innovation program is about. So together with Top Sector Energy, we're part of, with RVO, but also with NWO for academic research. There's a lot of funding available for these innovation projects. So we already called on the audience to bring forward those new ideas so we can set up more innovation projects to address, for example, robotization, automation in offshore wind. We're happy to have a look at any project.
I'm glad to see it's also encouraged in the tenders of late with the innovation CAVO in Borselen, for example.
Very important.
And I think we should not lose sight of that also in the current race towards 2030, 2035, to keep an offshore demonstration site to test, for example, your new tools, Jan-Jelle.
I think that's a really important one, because I was talking about physical places where people meet and from different corners and work together, also in a more systematic way. So not only on one project, but more systematically. But this an offshore maintenance park in which you test also and try out generating energy in different forms, wind, solar, how about the biology, etc. I think that's something a lot of people are calling for, and that would also be really good to stimulate.
Do we have another question?
Maybe a last question from the audience. It says, what was key for clients to accept innovations? That could be a question for you, maybe.
I think when they can really see the advantage. Because I think there are many types of clients, like users also. You have the front runners, the middle, the late adopters. And we like to work with the front runners, because then we can also add our innovations and try it, learn.
These are your launching customers in a way.
They need to, we need to sell it in a way that not an advantage only for us, but also for them. Very clear advantage, and that's something that sometimes, going back to the skills of technical people, sometimes communications skills is also an issue. With and that's something that we are really working on in our group to help people communicate better between fields, between multidisciplinary communication, because sometimes we had very funny discussions that I start looking, why are these people, why cannot they discuss? And then because of the meaning of the words, for example.
If you combine people work on ethics and work on, say, engineering,
it's a whole game.
But maybe also the same question for Jan-Jelle. So what made your client accept your innovation? Because it was new.
There are some EPCI contractors who push for development themselves, and therefore they sort of requested it, making it or actually promoted it towards their client. So you sort of promote it together, us as in that case the subcontractor and the contractor. Sometimes there are clients that push for innovations in the tender phase, so they're stating that the EPCI contractor needs to perform a certain task. For example, diverless, and that's our main thing. So if they claim that, and the EPCI contract says, well, we don't know how to do that, they come to us, and then you start up an innovation. So as I mentioned before, now that we have done some projects and we have some good experience with automating those specific tasks, you notice that clients come back, they gain confidence, and that gets the ball rolling.
Well, thank you.
I'm also curious, Jan-Jelle, when it's also for your company the next step to cut the cord at some point, to go tetherless and not have any more people there on the support vessel? What's your view?
This is a good question. We're not looking into that at the moment. I'm sure at some point we'll definitely get closer to that area. But what we notice is that there's a really clear difference in the market to what you can autonomously do. As you say, cut the cord, particularly subsea communications. Wireless is very difficult, so you need to do some mission planning. For example, wind farms, to inspect visually wind farms, it's relatively easy to do that. But we also have a lot of work in the oil and gas industry, and this makes it extremely difficult. So for us, only to remove or minimize the diver component on the inspection tasks is our main challenge and what we are focusing on. And I don't see it happening that this will be fully done from onshore, as the operations are simply too complex. Where I see this happening is in the very recurring and very easily automatable tasks, like the inspections of wind farms, as these typically are monopiles, so they're relatively simple structures to inspect. So this is something, where the industry will start doing this, but we're not developing tools for those kind of tasks yet.
Maybe a challenge for the coming years then.
I think lots of challenges for the coming years. We can talk about this for hours, I think, but this hour has nearly come to an end, and I want to thank you all for your insightful conversation and contribution to this discussion. Let's wrap things up. Bob, always the last final words for you on robotization and human capital.
Yeah, well, it's a fascinating subject, that's clear. At many dimensions, from ethics to technology, but also in working together. I think what was really important here, what came to the table, was that the combination between, say, innovation on robotization, with education, with companies actually working on this technology and also make it acceptable to the market. I think that's really an important call. So working together on these aspects is critical. Also to include, I would say, other fields of expertise, like the regulatory side. If this turns out to be like an inhibiting factor later on, I think we've got a problem. And they've got the robots, but they're not allowed to work for whatever reason.
And philosophy?
Yeah.
Absolutely, really alpha, beta, gamma.
It's absolutely, so it's a much more multidisciplinary subject than I initially thought. So that's very, I think, insightful. I think also the call that we make, so if you have innovative ideas, and it seems that robotization, a wider definition, we also learned that from Bernadete, that it's also automation, it's all those aspects, really starts already in, say, the manufacturing, or maybe even earlier in design, manufacturing, transport, installation, and maintenance. So there are so many opportunities there to get rid of the 3Ds or 4Ds. Especially, I think, the dangerous part, safety, also mentioned by the students initially. The safety aspects are really an important driver for this. So I think we've really set the scene for further innovation in this area. I think it's very inspiring.
It is 4 o'clock right now, but do you have really quick, you want to share some other subjects with the audience?
Well, maybe for the next events that we're organizing. So we are working on, say, a complete revision and overhaul of our innovation program, our multi-annual mission-driven innovation program. And we will be consulting you, the audience, but also a lot of specialists in the market for this. And on the 8th of November, we'll have another webinar on this very subject of the innovation program. Thanks for being able to announce that.
And the 8th of November, so is about the value of nature of the North Sea, TKI Wind op Zee.
Yes, so we'll be looking at the value of the... sorry, I was mixing up two things. So one is the say revision of the innovation program, and the 8th of November, in fact, is the webinar about the value of nature on the North Sea. Thanks for correcting that.
So, thank you all. Thank you for my guests joining us online and here at the table. Barbara, Koen, Bernadete, and Jan-Jelle. Thank you, Bob, for being here always. And thank you, the audience, for watching. Please let us know how you appreciate this edition, and we would love to see you on the 8th of November when we'll continue TKI Wind op Zee live. Thank you.